Hello again. I'm here with another video related to power transmission uh, from one point from this motor here at A, which is rotating at certain speed and transmitting a certain power to a machine tool at D. And as you could see, we have two gears here, gear B with a radius of 75 millimeters and gear C with a larger radius of 125 millimeters. So our objective is here, if we're given that, for example, that the motor at A is to transmit, say, 10 kilowatts of power, okay, via this the two shafts A, B, and by the way, both shafts A, B, and CD are solid. To transmit the power from a motor at A to a machine tool at D. So if we know that the shaft of the motor is rotating at a speed of, say, 20 hertz, and as you know, hertz means revolution per second or cycle per second. This should be converted to radians per second. We'll do that in a minute. Okay, so we're transmitting 10 kilowatts, rotating at 20 hertz. Assuming that the material property of both shafts AB and BC, so shafts AB and CD are made of the same material, let's say some type of steel, for which the allowable stress or the maximum stress is 60 megapascal. So based on that, what we are trying to find then is the minimum diameter of shaft AB and minimum diameter of shaft CD. Okay? So again, both shafts are solid. All right, so we start by saying, okay, if the power is 10 kilowatts and the shaft is rotating at 20 hertz, first of all, let's take this 20 hertz, which is 20 revolution per second, and use the conversion of one revolution is 2 pi radians, and that converts to 40 pi radians per second. Now, knowing that power is equal to torque times omega, we could then go ahead and find the torque. Now, this is the torque coming out of the motor, so that would be the torque on shaft AB, which is the same torque that is acting on gear B. So there would be a torque like that acting on that gear, and then a torque in the opposite direction will act on gear C. Anyways, so this torque would be the power divided by omega. So 10 kilowatts is 10,000 watts. Watts is Newton meters per second or joule per second. And omega is 40 pi radians per second. So you see how second and second cancel, radians is dimensionless. So this comes up to be about 79.58 Newton meters. So knowing that, so basically what we have here, we have two gears like this. This is gear B and this is gear C. So this is the shaft of CD going through here, and this is the shaft of AB. And the torque acting on gear C is proportional to, based on the radii of these gears, proportional to torque B. And the formula is very simple. The torque on gear C divided by torque on gear B is actually the ratio of the radius of gear C over ratio of gear B, which basically means the larger the torque, the larger the gear, the larger the torque acting on it. So the ratio of 125 to 75 basically is 1.67. So that's how much torque C is going to be larger than torque B. So that comes out to be about 132.6. So basically I'm just using gear ratio here. Okay, so ratio of RC to RB is 1.67 multiplied by T sub B, and that gives me the torque. So this is actually the torque now on shaft CD, 132.6. And from here, basically you've seen this in another video, that we know for a solid shaft, or for any shaft, tau is equal to tau max equal TC over J. In this case, for a solid shaft in particular, that tau max is 16 torque divided by pi d cubed. So you could actually go ahead and solve for diameter directly. That would be the cube root of 16 torque over pi tau max. So if you go ahead and do this for shaft AB, you have to use torque AB. So if you do 16 times the torque AB, which is, we got 79.58 based on the power transmission, right? Divided by pi, make sure you change the unit of 60 megapascal to 60 million pascal. This comes out in meters to be 0.0189 meters, or about 18.9 millimeters. So the minimum diameter for shaft AB should be that much. And similarly, you can do the same thing and find the diameter of shaft CD, which would be cube root of 16 times the torque here, 132.6 divided by pi, and the same material property, right? 60 megapascal. This time we end up getting 20.0224 meters, which is about 22.4 millimeters. As always, thank you for watching and listening.